Answer for number 1, please. Kinsey. Niner. Very good. Number 2. Blythe. 8. Very good. And 3. Yes, Lonnie. 22. Yes. Let me show you why it is 22, okay? 3 times t, t is 7. Is 21. Plus 1 is 22. Okay, before we move on to the next part, it's important for you guys to understand that you cannot combine letters or terms with letters with just numbers, okay? So, for example, give me some numbers. 7, 8, 12. That's good. Now I need some letters. I did say letters, right? That's a good one. There you go. All right, here's the thing is some of you would combine all of this. You'd say 7 minus 8 is negative 1 plus 6 is 5 minus 12 is negative 7. And you have negative 7 and u. Okay, that would be absolutely, completely false. Okay, let me show you what happens here is you got to find terms that are like each other. Okay, like this one, see how it has an n? This one has an n. That means that this term right here and this one right here, I can combine those two. Okay, so that would give me 7 minus 12n would be a negative 5n. Okay, now look, this negative 8 is just by itself. It doesn't have a u like this one does, so it's just negative 8. And the same thing with this positive 6u, so just have a positive 6u. This would be this term, this statement, simplified completely. First, let's look at this. Jordan buys 3 notebooks that cost $5 each. He also buys 3 packages of pens for $6 each. Okay, so how much did he spend? Well, there's a few ways we can look at this, and that is that how many $5 items did he get? 3. How many $6 items did he get? 3, right? Okay, so that's one way to look at it. Or we can say since he bought 3 of each, and then the cost was both $5 and then $6. Okay? Then by the order of operations, you just do this set of printhi first. Notice once again, I have 3 $5 items, which is where this part comes from. And then in addition to that, I'd buy 3 $6 items. So 3 times 5 and plus the 3 times 6. Does that make sense?
So why did you not include?
So the bottom one, since I bought 3 of each, that's where the 3 comes from. All I've got to do is combine the 6 and 5. So I say, well, I bought a $6 item and a $5 item, but I bought 3 of each.
So you
Does that make sense how I can do that?
Yeah. So
if I combine the two, if I bought one set, I'd have a $6 item and a $5 item, which would be 11.
So could you just do 3
times 10?
Yep, and that's what this is. Evaluate both expressions. What do they equal? What does this one equal? 33. Very good. And that would be dollars. What about either one of these? They're the same thing.
33.
Yeah, $33. Okay. So what did you notice about these two? The same. Hey, that was easy. All right. So as it turns out, there's no difference between either way that we do these. Number 4, we just need to circle the expression that represents this problem. Okay, so 5 notebooks at $3, and then also we're going to buy 5 packages of pens for $1 each. So which of the expressions would work? Very good. This one will work because you get 5 packages of $3 items, and then 5 packages of $1 items, and then the third one, right? You're buying 5 packages each of $3 and $1 items. Very good. What about this next one? If you buy 2 rulers at $1 each, and then 2 folders at $1.50 each, which of these 2 expressions would work? Yep, this one would work because you buy 2 sets of $1 and $1.50 items. This you're buying 2 $1 items and 2 $1.50 items. So this one's good. So let's look at this top expression. You'll notice, how many bags are there? 2 bags and how many coins? 4 coins, right? So there's a way that we can express this. We have 2 bags. Then we also have 4 coins. Now, one of the worst problems that we have is that, one of the many problems we have in math, is that when you're looking at this, you say, well, why don't I just take the 2 bags and add 4 coins and get 6 bags? Right? Isn't that what some of you did on the homework? Well, if I can simplify this to 6b, then we're good. Okay, but can I do that? No, I cannot, because I have bags and coins. They're different, right? Well, it's the same thing with this expression. Okay. Yes. Yes. Yes, as an expression, this stuff is equal to this.
So wouldn't that be 0?
What do you mean? Turns out there is another way we can express this, right? Does anyone notice what it is? No? Sydney?
1, 2 plus 1, 2. Wait, yeah.
You're very close.
So like 1 bag times 2, 2.
I don't know. Not completely sure what you mean, but let's see, okay? What?
1 bag.
Okay, well, we're not really...
Or 2 bags.
Well, there's 2 bags, so you do 1 bag.
I may have heard that wrong, but if I did, please forgive me, okay? Let's look at just one set of these, okay? Because there's 2 of these, right? Okay? So if I look at this first one, I have 1 bag, and how many coins? 2 coins. But in addition to that, I also have, again, 1 bag and 2 coins. Okay? Does everyone see that there? Deeper into this, I have 1 bag and 2 coins. But how many sets of those do I have? 2. 2 sets of those. So as it turns out, this would be another way to write this as an expression. Okay, does this make sense why you would not combine letters with numbers without letters? Because if you look at letters as though they're bags, you can't just combine them with coins. Okay. By the way, this is called the distributive property. Some of you may have learned about this in 4th grade, and they'll say, do the distributive property. Well, here's the thing is if you have just numbers like this one, I really don't care if you use the distributive property. Okay? Because the order of operations would make this much, much easier. Okay? Well, some of you, you can use the distributive property if you want, but it's not really completely necessary. So why don't we just subtract those 2 in the parentheses? 12 minus 4 is 8. And we'll multiply that by -5, which equals -40. Very good. All right? Now, some of you are thinking to yourself, well, self, I really feel like I have to do the distributive property, otherwise that'd be cheating. Okay, well, that's fine. Here's the thing is the distributive property looks like rainbows. Okay? Rainbows. This is a double rainbow, but don't cry about it, all right? So when you have double rainbows like this, sometimes you'll have triple and quadruple rainbows. All right? We'll show some examples of those. These rainbows represent what operation? Does anyone know what it is? Micah. Multiplication. This is multiplication, okay? So in other words, I'm going to take this term that's outside of the parentheses and multiply it by everything on the inside, which is why we have these rainbows. We have this rainbow and we have this other rainbow, right? So in other words, if I do it using distribution, I've got negative 5 times what? Well, 12. It's on the left. Minus, again, I've got the negative 5 times 4. Very good. Well, what's negative 5 times 12? Negative 60. Minus, what's negative 5 times 4? Negative 20, okay? Now this is the part that most people struggle with, because some of you are just going to put this as minus 20. But it's not minus 20, it's minus negative 20. So make sure you indicate that it is a negative. All right? The reason that is because if you subtract a negative, it's actually what type of operation? Addition. Okay? And these two would combine to make a negative 40, which is the same as what we got before. One of the greatest differences is that one takes much longer than the other. Right? So you get to choose. Find our problems like this one. Okay? Well, if we look at this as though we're bags and coins, if I have 2 bags, but I have 5 sets of them, how many bags do I have? 5 sets of 2 bags would give me 10 bags. That's B. And if I add this to 5 sets of 8 coins, how many coins would I have? 40 coins. Can I combine bags and coins? Nope, it's done. That is as simplified as it will be. So give me some numbers. 5, 6, 9, well, 2 is good. She's an 8. That's good. All right, let's see. Let's make that a negative, a minus. Give me a letter. P is good. I heard P. Oh, that's good. That's good. Thank you, though. All right. Well, this one's a very interesting one because here we have 5 minus 6 in this parentheses, negative 9 minus 2p, and then plus 8. Okay? The question is, what number do we distribute and where do we distribute into? Okay, so let's start with the first question. What number are we distributing? Micah.
I just forgot.
What number are we distributing?
Oh.
Ashley? What? No, we are definitely not distributing 8. Lonnie?
5 minus 6.
It is negative 6. How many of you thought it was 6? That will admit it. 1? Okay. 2? Yeah, that's usually what most people would think is that, well, 6 is outside the parentheses, and then I would just distribute the 6, okay? Before I explain why it's a negative 6, what operations between 6 and the parentheses? Multiplication. Does that make sense why we multiply as we distribute? Okay. All right. Well, let's look at this. Why is this negative 6? Well, let's find out, okay? Let's say that I was to add a negative 6 like this. Is that any different than 5 minus 6? Well, no, because I could just make that a big fat minus sign and call it good. All right? So as it turns out, it doesn't even matter if it is just 5 minus 6. Okay? So let's just make it 5 minus 6. All right. So we have 5. We've got this plus 8 at the end. And remember, you're only distributing into the parentheses. All right? Some of you would look at this and think, maybe I would just want to distribute the 6 into the 8. Do not do it. All right? All we're doing is distributing inside the parentheses. Okay? All right, well, let's look at this first part. So what is negative 6 times negative 9? It's our first rainbow. What's that? It's a negative 6 times negative 9 would be a positive 54. We indicate it's positive with the plus sign, right? And then we have minus, okay, the operations in between always stays the same. The only thing is we got negative 6 times 2 here, right? So what's negative 6 times 2p? It's negative 12p. All right? Well, the problem is here I've got this, I have this minus negative stuff, right? Well, since it's minus a negative, what operation is that going to be? That's a big fat plus, right? Okay. All right, well, now we combine terms that are alike. So notice here we've got 5 coins and 54 coins and 8 coins. How many coins total is that? 67 coins. And how many bags? 12 bags. Done. So give me some numbers here. 5, 2, 12. That's good, that's good. Okay. All right, give me a letter.
D.
X is good. That's good, thank you. All right, here's the thing is now we have this 5 and we have a large set of printhi, okay? Now instead of 2 rainbows, how many rainbows will we have?
3, 4, 5.
How many rainbows?
4.
4. Well, what if I changed it and added 6? How many rainbows?
4.
4. Okay? Because why would I not distribute to the 6?
It's not in the parentheses.
Because it is not in the parentheses side. Okay? All right, so I distribute the 5 in here, like this, up in here. So 5 times this, remember, is multiplication. 5 times 2 is 10. I keep this minus. 5 times 12, x, would give you 60 x's. I'm going to keep that plus. 5 times 7, 35. We'll keep the minus. 5 times 3x, 15x. Very good. Plus the 6. Now I can really start simplifying here and combining terms. If I have 10 coins, 35 coins, and 6 coins, I have 51 coins, okay? And notice these are just going to be negative bags. How many negative bags do I have?
75.
Negative 75 bags. Very good. This is this statement simplified. All right, so once again, you guys can use the distributive property here if you want, but it's not really necessary, right? I could just do negative 9 plus 4 and then multiply it by the 8, which is negative 4. Try A, B, and C. All right, what's the answer for A? Kinsey.
15. Negative 45 plus
10.
What?
10.
Negative 45 plus 55, which equals 10. Very good. All right, what is the answer for B?
70 minus 35. Oh, I
35. Right. Good. What about C?
36.
36. You guys another example where people struggle, okay? So give me a number.
18.
Sure, 18 is good. Give me another one. 2 is good.
9.
All right. Here's the thing is when you distribute this 18, so you're going to distribute to both places, right? So there's our rainbows. What's 18 times x? 18x, okay? Plus 18 times 2?
18. 36.
36, okay? Now the reason I point this out is because 18 times x is something that some people struggle with. Mr. Sal, what is 18 times x? Well, if it helps you, put that phantom 1 there. Okay? 18 times 1 is 18, and then at the x, 18x. Okay? Here's a couple more examples. Again, notice when you distribute the 4 into the x, it's just 4x. 4 times x is 4x. Okay? Same with p. 6 times p would give you 6p. Notice also that in examples 2 and 3, the operation here in the original operation here is the same as it is in the end. So if we look at 4, Why is it that this is minus, but now it's plus? Why did the operation change there?
Because it's a negative.
What do you mean, Sydney, that it was a negative?
Because you have to do negative 2 times 2, so that's 2.
Excellent. Notice the 2 in front is negative. If you're ever distributing a negative, it's going to change the operations.
So if it's like a positive, then it changes.
Let's look at how that would affect it, right? Let's take negative 3. We'll just make it a little different, okay? And we'll make it, I don't know, z. Z, and you want it plus?
6.
True, 6 is good. Okay, well yes, in this one, you're going to distribute the negative 3, so that's negative 3z there. And to the 6, this would be 18. But it is going to change this operation to minus now. Question, notice how the z was positive, but now it became a negative here. What this means is when you are distributing negatives, it changes both the operations and the signs. So it'll change the sign of the first term, and it'll change the operations throughout. One, don't combine different types of bags. See how this is an X bag and this is a Y bag? Yeah, don't combine those either. Okay, so negative 3 plus 7. Some of you would say this is a negative 4xy. That's very, very bad. All right, don't do it. Oh, also you'll need to be distributing negatives. This is very good. I'm sorry, fractions. You will need to distribute fractions, but since we've done so much work with fractions, this should be good. All right, do these 4.
Okay.
Would someone like to write the answer for D, please? All right, Carly has volunteered to write our answer for D.
Go, Carly.
There you go. Well, that's very good. Let's finish these 4 real quick. E for tan or.
Just gonna.
Bam. Nailed it. Good job. Lonnie. All right. This is very, very, very close. Okay? Right? Very good, yep. So I just, there you go. That's better. All right, Ashley, we'll do G. Was your hand up?
Yeah. Both of them were up, actually.
Actually, what? What?
Maybe that's why I didn't see
Good
you.
job. Thanks.
That's very good.
Is that right?
It is right. That's excellent. Yeah, because 1/2 times W is just, well, it's 1/2 W. 4 times 1/2 is 2, so that's good.
Would it be adding? Yeah, we're
All right, listen, on this example, they want you to use distributive property, but really there's no need, because if the helmets are $19.95 each and you buy 9 of them, just multiply the 2. Be done with it. You have calculators, just do it. And with this one, if it costs $37.50 to rent a bike and you rent 20 bikes, just multiply the 2. All right, $150. All right, do these 4.